Hello, future network associates. This is Whale Hater. We're doing a brand new packet tracer today. This one's exciting because it's the very first packet tracer of course number 3. Yes, you heard me right. Course 3 for the CCNA course certifications. We're doing packet tracer 1217. We're going to be looking at the differences between layer 2 and layer 3 devices today. So, very first thing off the bat, examine the physical aspects of D1 and ASW1. These guys right there. There's the physical. There's the physical. All right. Each individual switch has how many physical interfaces? Well, this one has 24 fast Ethernet switches, ports, and has 2 gigabit Ethernet ports. This one has a console port in addition. So in total, this one's got 27. This one up here has got 26. How many fast Ethernet and gigabit Ethernet interfaces does each one have? Well, 24, 2, 24, 2. List the transmission speed of the fast Ethernet and gigabit Ethernet interfaces on each switch. Let's do that. You'll notice here for fast Ethernet 1, it has full duplex 100 megabits a second. Now let's just jump down to the bottom. We have for our gigabit Ethernet number 1, we have full duplex 1000 megabits a second. Notice the same thing, full duplex 100 megabits a second, and bam, right there. The gigabit Ethernet's got the same speed as the other. So they're both similarly paced. Are either of the two switches modular in design? Now you'll notice these are not modular switches. They're standalone fixed configuration switches. They do not and cannot be inserted into a modular cabinet. A modular switch would be just a big cabinet with a main controller with an extended backplane, and you're just going to start inserting blades into the larger cabinet. The blades are cheap. The initial switch is very expensive, but to grow, they're very cheap to grow. So those are nice. But those are not modular, so no. The interface of a 3560 switch can be configured as a layer 3 interface. Now listen up, boys and girls. Here's important information coming up. By entering the no switch port command in interface configuration mode. This allows technicians to assign an IP address and subnet mask into the interface the same way it is configured on a router's interface. You might want to read that again just so let it sink in. All right, what is the difference between a layer 2 switch and a layer 3 switch? Layer 2 switches, those are all examples thereof, only operate at the layer 2 of the OSI model. What addressing is at layer 2 of the OSI model? Yep, layer 2 deals with MAC addresses. What layer deals with IP addresses? Layer 3. All these are layer 3 devices. What is the difference between a switch's physical interface and a VLAN interface? Physical interfaces can be plugged, a cord can be plugged into them. Okay? VLANs are virtual local area network interfaces, and they are, like I said, virtual. They don't have physical being in reality. It's just internal to the switch. On what layer do the 2960 and 3560 switches operate? Well, let's look it up. You can see the model number at the very top right here. There's the model number. And this is a layer 2 device. Same thing over here. Go over the command line, zip to the top, 3560. And it is a layer 3 device. What is the difference between the switches? Oh, duh. Issue the show run command to examine the configurations of D1 and ASW1 switches. Do you notice any differences between them? Alright, so there's D1. Come on, G. Alright. So for the layer 3 device here, straight away we've got IP routing as an option. Nothing here on this side. They both have the same number of ports, although this one has its gigabit Ethernet ports. They have been addressed. Notice the no switch port command. Haha. And everything else I think is pretty much the same. This one's got a 5 to 15 range on its VTY lines. This one has only up to 4. I don't know if that matters for a description, but that's that. Display the routing table on both switches using the show IP route command. Why do you think the command does not work on ASW1 but does on the D1? Let's just answer that by saying, without having to actually do it, ASW1 is a layer 2 device. Layer 2 devices don't have routing tables because they don't operate at that level. D1, it would work there because, well, of course, it's a layer 3 device. Now moving forward, up until recently, switches and routers, you can read that if you'd like. Open the physical tab on D1 and R1. Here's the physical for D1. Guess we're done with that guy. Alright, so we got that. Do you notice any similarities between the two? Well, they both have a Cisco logo on them. Other than that, there's not too much similar, is there? Other than it's got a couple of gigabit Ethernet ports here, and then there's a couple of gigabit Ethernet ports over here as well. That's about it for similarities. Oh, and they have on-off switches. That's yeah, not too much. Not too much the similarity. Oh, this one has an on-off switch. This one just you unplug. I forgot that about switches. They don't have on-off switches. Okay. Issue the show run command and examine the configuration of R1 and D1. What differences do you see between the two? So there's that. There is this one, R1. Alright. So this one has a configuration of 1292 bytes. That's kind of a lot compared to his 775. Other than that, there's a version difference, but those are differences because this one's a switch, this one's a router. The host names are different. Similarities, there's a few. Here's also something that's not listed on the router. It says IP routing. That's special because that's a switch, and it's saying, hey, this is a layer 3 switch. Over here, it just is assumed because it's a router. This one is licensed, got a license number. This one has none. This one's got a whole buttload worth of fast Ethernet ports. Nothing over here except for the gigabits and the serials. Now those are similar, but it doesn't have any serial interfaces. This one does. Other than that, not a whole lot different after that. What's next? Which command allows D1 to configure an IP address on one of its physical interfaces? Do you remember what I was telling you over here? Super important. You want to know that command. You'll definitely be using it later in this course, I assure you. Let's do it. Interface F01. We'll just pull up that interface on the layer 3 switch. Now let's try to give it an IP address on this one, right? This is what the command we use. Oops, we'll just do that layer, we'll do a class C network. And it didn't work because we didn't give that no switch port. I'm so used to saying show. Okay, no switch port. Enter, now double up arrow, enter again. It worked that time. You see how we got that to not give us an error? Let's do a do show run. And you'll notice right here, Ethernet 1, interface 1, no switch port command has been enabled, And it has an IP address now. Isn't that cool? Pretty handy. That's a routable interface now. It's not just a switchable interface. So those two commands will do that. Use the show IP route command on both devices. Do you notice any similarities or differences between the two tables? Okay, so here is that and that. And let's do you'll notice on the layer 3 switch, it only has 2 ultimate routes. Where can we go from here? This one and this one. Over here on the router, it has parent routes, and it has it's got child ultimate routes. There and there. Also, it's got its local address on that network listed as well. So there's a lot of differences there. There's a couple of similarities, but mostly different. Now analyze the routing tables of R2 and D2. So we're done with these guys. So pull up R2, enable, show IP route. Oh, there's some differences already, I see. All right, what are we seeing? First of all, on D2, yes, it does have some parent routes. This time it does. But it also has an EIGRP route that is learned through the EIGRP protocol. R2 told D2 about, hey, there's this route out there to this network. If you want to get there, here's how to do it. And R2 also learned about a couple of networks that R2 didn't know about previously, and I'm imagining it's these 2 networks here. Saying, hey, if you want to know about these, if you need to get there, here they are. Those are available to be routed to. Verify the topology has full connectivity by doing pings. Now you can go ahead and do that. We're not going to do that for the sake of time. In all 3 examples, each PC is on a different network. Duh. Which device is used to provide communication between networks? As we've said before, layer 3 devices allow for routing between networks. Why were we able to ping across networks without there being a router? Excuse me. Routers work at layer 3. So do layer 3 switches. You can use them to route between we can use them to read IP addresses and to route them accordingly. That's why. So PC1 doesn't need a router to go to PC2 because this layer 3 switch is acting like a router. Similarly, over here, PC5 sends its ping request to PC6 up to D2. D2 is a layer 3 device. It doesn't have to forward it to R2 to figure it out. D2 knows all about how to route packets. So it routes the packet, or it figures out where it needs to go, encapsulates it in a frame, sends that frame down to PC6, and PC6 says, oh yeah, that's for me, and then it sends a reply, and back and forth, back and forth. So that's it. Hey, we're at the bottom. We did it. We got all the way through. Congratulations. Ta-da-ta-da. Well, thank you very much for watching. If you have any questions, please comment below. I love helping you guys out, but I can't help you if you don't ask. So please ask, and also please subscribe. We're coming out with new videos all the time. Talk to you guys later. Peace.